Imagine a future where technology is not just faster, but exponentially powerful. What could this mean for us, and how close are we to this reality? Look no further than quantum computing, a cutting-edge technology that sits on the horizon of our technological future. A realm where the rules of classical computing give way to the strange and fascinating laws of quantum mechanics. Quantum computing is not just a faster way to compute, but a fundamentally different way to process information. In the world of classical computers, information is stored in binary digits, or bits, each bit representing either a 0 or a 1. But in a quantum computer, this information resides in quantum bits, or qubits, which can represent both 0 and 1 simultaneously, thanks to a quantum phenomenon known as superposition. This allows a quantum computer to perform a vast number of calculations simultaneously, potentially solving complex problems that are currently out of reach for even the most powerful classical computers. But that's not all. Quantum computers also leverage another quantum marvel known as entanglement. When qubits are entangled, the state of one qubit is directly correlated with the state of another, no matter the distance between them. This means that a change in one qubit can instantaneously affect another, allowing for incredibly fast information processing. The implications of this technology are immense. From cracking encryption codes to simulating complex biological systems, to optimizing intricate logistics problems, quantum computing holds the potential to revolutionize many aspects of our lives. However, it's important to note that quantum computing is still in its infancy. Scientists and engineers around the world are grappling with the challenges of building reliable, scalable quantum computers. But every day we inch closer to this exciting reality. So, what exactly is this quantum computing, and how does it promise to alter our technological landscape? Let's dive deeper into the quantum world in the next scene to unravel the mysteries of this game-changing technology. In its simplest terms, quantum computing is based on the principles of quantum mechanics. Now, quantum mechanics is a branch of physics that deals with phenomena on a very tiny scale, such as atoms and subatomic particles. It's a universe where the conventional rules of physics seem to be thrown out of the window and replaced by a set of rules that can be, quite frankly, mind-boggling. Imagine, if you will, a coin spinning on a table. We're used to a coin being either heads or tails, but in the quantum world, that spinning coin is both heads and tails at the same time. This is the principle of superposition, where a quantum particle can exist in multiple states simultaneously. Now, let's take two spinning coins, each in a state of superposition. In the quantum world, these coins can become entangled, meaning the state of one coin instantly affects the state of the other, regardless of the distance between them. This spooky action at a distance, as Einstein called it, is the cornerstone of quantum entanglement. So how does all of this tie into computing? Well, classical computers use bits, which are like our coins but can only be in one state at a time, either a 0 or a 1. Quantum computers, on the other hand, use quantum bits or qubits. A qubit, like our spinning coin, can be both a 0 and a 1 at the same time, thanks to superposition. Furthermore, thanks to entanglement, a change to one qubit can instantly affect other entangled qubits, no matter how far apart they are. This allows quantum computers to process vast amounts of information simultaneously, offering potentially unprecedented computational power. Now, armed with a basic understanding of quantum mechanics, let's delve into how a quantum computer actually works. A quantum computer, unlike a classical computer, processes information in a unique way. It's like comparing an electric guitar to a grand piano. Both can make music, but the sounds they produce and the mechanics behind them are worlds apart. In a classical computer, information is processed using bits, the smallest units of data that can be either a 0 or a 1. Each bit is like a single note, played one after the other to create a melody. But a quantum computer doesn't play by these rules. Instead, it uses quantum bits or qubits. And this is where the magic happens. Just imagine a piano that can play multiple notes at the same time, each note representing a different possibility. This is the concept of superposition. A qubit, unlike a bit, can be both 0 and 1 simultaneously. It's as if it exists in multiple states at once, giving a quantum computer the power to process a vast number of possibilities simultaneously. But that's not all. There's another quantum phenomenon at play: entanglement. Picture two pianos in different rooms. When one piano plays a note, the other piano plays the exact same note at the exact same time, no matter how far apart they are. This is what happens when qubits become entangled. The state of one qubit can instantly affect the others, no matter the distance. This interconnection, this shared existence, enables quantum computers to solve complex problems at an astounding speed. In the grand symphony of computing, a quantum computer is like an entire orchestra, with each qubit playing a different note, yet all working together in perfect harmony. Each note, each qubit, influences the others, creating complex melodies that classical computers can only dream of playing. With this, we can start to see why quantum computers promise such extraordinary computational power. With such power, quantum computers could drastically change our world. This is not a mere conjecture, but a statement grounded in the potential of quantum computing. Imagine a world where complex problems currently insurmountable for classical computers are solved in mere seconds. Consider cryptography, the art of writing and solving codes. It's the invisible wall that keeps our digital world secure. Today's encryption methods rely on the fact that classical computers can't efficiently factorize large numbers. However, quantum computers, with their superior processing power, could crack these codes like a nut, redefining our concepts of digital security. Now let's talk about weather forecasting. Predicting the weather accurately is a complex task that involves crunching a colossal amount of data. With their ability to process multiple possibilities simultaneously, quantum computers could provide us with more accurate weather predictions. This could be a game changer, particularly when it comes to predicting severe weather events and mitigating their impacts. In the realm of drug discovery, quantum computers could be a boon. The process of developing new drugs is time-consuming and costly, often taking years and billions of dollars. Quantum computers could simulate the interactions between molecules and drugs with unprecedented accuracy, potentially speeding up the discovery process and reducing costs. And then, of course, there's artificial intelligence. Quantum computers could drastically accelerate machine learning, allowing AI to evolve at a pace beyond our wildest dreams. This could lead to breakthroughs in fields as diverse as healthcare, finance, and autonomous vehicles. However, it's important to keep our feet firmly on the ground. While the potential of quantum computing is immense, the journey to fully functional quantum computers is fraught with challenges. Error correction, stability, and scalability are just a few of the hurdles that need to be overcome. But let's not lose sight of the potential. Quantum computing could revolutionize our world, transforming how we solve problems and opening up a universe of possibilities. However, the journey to fully functional quantum computers still has many challenges ahead. The road to quantum computing is filled with hurdles, but the potential rewards are enormous. The quantum realm is a tricky one to navigate. The very nature of quantum mechanics, with its superposition and entanglement, makes it challenging to maintain quantum coherence. This is the ability of a quantum system to sustain its properties over time. A major hurdle in quantum computing is the high susceptibility of quantum bits, or qubits, to errors caused by their interaction with the environment, a problem known as quantum decoherence. Yet, these challenges haven't dampened the enthusiasm of researchers and developers. The field is bustling with continuous advancements, with researchers around the globe working tirelessly to overcome these obstacles. Some are experimenting with different types of qubits, while others are developing new algorithms and error correction techniques. The race is on to build a universally programmable quantum computer, a device that could revolutionize everything from cryptography to drug discovery. The potential impact of quantum computing on society is both thrilling and daunting. On one hand, it could usher in a new era of scientific discovery and technological innovation. Quantum computers could help us solve problems that are currently out of reach for even the most powerful classical computers. They could revolutionize fields like material science, medicine, and artificial intelligence. On the other hand, the power of quantum computing also brings with it notable risks. It could render most of today's encryption methods obsolete, posing significant challenges to data security. There are also ethical and societal questions to consider, such as who will have access to this technology and how it will be regulated. Only time will tell how quantum computing will reshape our world. But one thing is certain: the quantum revolution is on the horizon, and it promises to be a game changer.